Hey, what's going on, guys? Let's look at this problem right here. This question is asking a positive meniscus lens with an index of refraction of 2.4 is immersed in a medium of index 1.9. The lens has an axial thickness of 9.6 millimeter and radii of curvature of 50 millimeter and 100 millimeter. Compute the system matrix when light is incident on the convex face and show that its determinant is equal to 1. Now here they are asking to solve the system matrix. Now the system matrix for a meniscus lens is going to look like this. So 1 minus d2 d over n. Okay, let's get rid of this one. Okay, 1 minus d2 d over n, and then in the other side we are going to have d1 minus d2 plus d1 d2 d over n, and d over n, and then negative 1, actually 1, not negative 1, 1 minus d1 d over n. So here this d represents the thickness of the lens, and n is index of refraction of the lens. Now let's put L for L to identify that one. So this is the thickness of the lens, index of refraction of the lens. Okay, and this d1 is representing the power in the first medium of the lens, and the d2 represent power of the second, actually power of the first surface. Lens is going to have two surfaces, so this is d1 is power of the first surface and d2 is the power of the second surface. Now let's look at the given informations. Here we have radius of curvature is 50 millimeter, this one, and okay, thickness is here 9.6 millimeter. So we have this d value, that is 9.6 millimeter, and also we have the index of refraction of the lens, that is 2.4. NL is 2.4, and d1 and d2 we have to calculate. These two are not provided. Now to find the d1, what we do is we look at the first surface. Okay, so the equation is going to be n index of refraction of the first surface minus NL, actually nm, medium of index of refraction of the medium, so let's put nm, and then radius of curvature. So this is for the first medium, I mean first surface, so power of the lens in the first surface, power of first surface. Now we have to find the power of second surface, power of second surface. Now power of second surface, again d2, but in this case medium is going to be this one minus n, let's put this one in I1, let's put this one in I2, and divided by the radius of curvature. Now index of refraction of the lens is 2.4. Let's plug that one right here, 2.4, and here the medium is 1.9. Index of refraction of the medium is 1.9, and the radius of curvature in the first surface, that is 50 millimeter, and if you calculate this one you should get 0.01. And let's look at the second one. For this one we are going to have nm, that is 1.9, and index of refraction of the lens is 2.4, and then divided by the radius of curvature, that is 100, and here you are going to get negative 0.005. Now we have these two information, we have d1 and d2. Now we can find this matrix, we can solve for this matrix. Here they are asking to show that determinant is equal to 1. Now let's plug all the values. A is equal to 1 minus d2, we found out that is negative 0.05, negative 0.05 times the thickness, that is 9.6 millimeter. So 9.6 millimeter, let's keep it in millimeter because this is also, we have everything in, we used everything millimeter, right? So we don't have to worry about the unit because everything is in millimeter. This is in millimeter. So 9.6 millimeter divided by 2.4, and here we have 9.6 divided by 2.4 because d over n, d is the thickness 9.6, n is the index of refraction 2.4, and in the other side we are going to have, we need to have a big space. Let's get rid of this, and also let's write it in a different color. A is equal to 1 minus d2, we found out that is negative 0.05, negative 0.05, 1 minus negative 0.05 multiplied by the thickness, that is 9.6, divided by the thickness of the divided by the index of refraction of the lens, that is 2.4, and in the bottom we have d over n. D is the thickness 9.6, n is index of refraction of the lens, that is 2.4, and here we have this one. Let's get rid of this one too. Let's write this one on top. So d is equal to 9.6 millimeter and NL is equal to DL. NL is equal to 2.4. Okay, now let's go ahead and plug for this one. Negative D1 is going to be 0.01, and minus D2 is going to be negative 0.05, minus minus, that's going to make this one plus. Okay, and also we don't need this bracket. 0.01, this is plus 0.005, d1 times d2 times dl. d1 is 9, d1 is this one, 0.01, 0.01 times negative 0.005 times the thickness, that is 9.6, divided by this one, divided by n, that is 2.4. Okay, now let's get clear. 9.6, and this thing, you know, I had to write this one a little bit clear because it's going to ruin everything. Minus d1 is going to be 0.01, minus d2 is going to be negative 0.05, so that's going to become positive 0.05, plus d1 is 0.01 times d2 is negative 0.05 times the thickness is 9.6 divided by the index of refraction, that's going to be 2.4. Okay, now let's go to the bottom part. 1 minus d1 is going to be 0.01 times the thickness is 9.6 divided by the index of refraction, that's going to be 2.4, and we get this one. And if you simplify everything, you will get, this is going to be 1.02, and this is going to be negative 0.0052, and here you're going to have 4, and this is going to be 0.96. And here the question is asking to show that determinant is equal to 1. Now let's find the determinant. For 2 by 2 matrix, you just have to multiply this one, AD minus BC. Okay, AD minus PC, yeah, AD minus PC, and if you do that you will get 1.02 times 0.96 minus negative 0.0052 times 4, and if you do that you will get 0.9792 plus 0.0208, and that's equal to 1. And that's the question is asking. They are asking to compute the system of matrix when the light is incident on the convex face and show that its determinant is equal to 1. And we have shown this is equal to 1. And that's how we do this kind of problems. I hope this helps. Thanks for watching.